Hello guys and welcome back. Today is part 6 of AC motor control methods. We're going to talk about consequent pole motor control. We're going to talk about markings for a 2-speed, 1-winding motor controllers and the motor. We're going to talk about the purpose and function of a 2-speed and 1-winding motor control starters and motor. And we're going to talk about the connections of 1-winding controller and motors and two-speed starter with reversing controls and the recommended troubleshooting solutions for these motors and controllers. So let's get started. Certain applications require the use of a squirrel cage motor having a winding and range so that the number of poles can be changed by reversing some of the currents. If the number of poles is doubled, the speed of the motor is cut approximately in half. The number of poles can be cut in half by changing the polarity of alternate pairs of poles. The polarity of half the poles can be changed by reversing the current in half the coils. If a stator field is laid flat, the established stator field must move the rotor twice as far. If a stator field is laid flat as in the following image, the established stator field must move the rotor twice as far in B as in A. The same amount of time. As a result, the rotor must travel faster. The fewer the number of poles established in the stator, the greater is the speed in RPM of the rotor. A 3-phase squirrel cage motor can be wound so that 6 leads are brought out. By making suitable connections with these leads, the windings can be connected in series, delta, or parallel Y. If the winding is such that a series delta connection gives the high speed and the parallel Y connection gives the low speed, the horsepower rating is the same at both speeds. If the winding is such that the series delta connection gives the low speed and the parallel Y connection gives the high speed, the torque rating is the same at both speeds. Consequent pole motors have a single winding for 2 speeds. Extra taps can be brought from the winding to allow reconnection for a different number of stator poles. The speed range is limited to a 1:2 ratio, such as 600 to 1200 RPM or 900 to 1800 RPM. 2-speed consequent pole motors have one reconnectable winding. However, 3-speed consequent pole motors have 2 windings, one of which is reconnectable. 4-speed consequent pole motors have 2 reconnectable windings. Referring back to the motor connection table, note that for low-speed operation, T1 is connected to L1. T2 is connected to L2. T3 is connected to L3. And T4, T5, and T6 are connected together For high-speed operations, T6 is connected to L1. T4 is connected to L2. T5 is connected to L3. And all other motor leads are open. The above image illustrates the circuit for a size 1 selected multi-speed starter connected for operation with a reconnectable constant horsepower motor. The control station is a 3-element fast, slow, and stop station connected for starting at either the fast or low speed. The speed can be changed from fast to slow or slow to fast without pressing the stop button between changes. If equipment considerations make it desirable to stop the motor before changing speeds, this feature can be added to the control circuit by making connections E and A by the dashed lines. 3, 2, 1. Adding these jumper wires eliminates push button interlocking in favor of stopping the motor between speed changes. This feature may be desirable for some applications. Connections for the addition of indicating lights or a 2-wire pilot device instead of the control shown also given. The compelling type control. These connections mean that the operator must start the motor at the low speed. This controller cannot be switched to the fast speed until the motor is running. When the slow button is pressed, the slow speed starter S and the control relay FR are energized. Once the motor is running, pressing the fast button causes the slow speed starter to drop out. The high speed starter is picked up through the normally closed interlock contacts S of the slow speed starter and through the normally open contacts of control relay FR. The normally open contacts of control relay FR will now close. If the fast button is pressed in an attempt to start the motor, nothing will happen because the normally open contacts of control relay FR will prevent the high-speed starter from energizing. Mistaken reversal caution. When multi-speed controllers are installed, the electrician should check carefully to ensure that the phases between high and low speed windings are not accidentally reversed. Such a phase reverse will also reverse the direction of motor rotation. The driven machine should remain disconnected from the motor until an operational inspection is completed. The upper oil inspection plugs, also called pressure plugs, in large gear reduction boxes should be removed while testing the machinery. Failure to remove these plugs may create broken casings in the motor if the motor is reversed accidentally. Machines can be damaged if the directional rotations change from that for which they are designed. In general, the correct rotational direction is indicated by arrows on the driven machinery or in the back. 2-speed starter with reversing controls. In the following image, an elementary diagram of a 2-speed reversing controller The desired speed, either high or low, is determined with a two-position selector switch. The direction of rotation is selected with either the forward or reversed push buttons. When the power contacts F or R are closed, current is applied for the high-low controls. Assuming that the selector switch is in the high position, contactor L is energized to start the motor in low speed. At the same moment, timing relay coil TR is energized. When the normally closed delay in opening contact TR opens, after preset timing delay, normally open contact TR closes at the same time. This operation drops out contactor L and the normally closed interlock L energizes contactor H. The motor is now at high speed. The motor may be started in low speed in either direction before it is transferred to high speed. If the low speed is to be maintained, the selector switch is turned to low in order to open the circuit supplying the timing relay coil TR. This coil will normally transfer the control to high speed operation. 3-speed consequent pole motors. Consequent pole motors that are intended to operate with 3-speed contain two separate stator windings. One winding is reconnectable like the winding in a 2-speed motor. The second winding is wound for a certain number of poles and is not reconnected. If the reconnectable windings were to be wound for 4 or 8 pole connection, the motor will develop synchronous speed of 1800 RPM, 1200 RPM, or 900 RPM. 3-speed consequent pole motors can be wound to produce constant horsepower, constant torque, or variable torque. Examples of different connection diagrams for 3-speed 2-winding consequent pole motors can be seen in the above image. Four-speed consequent pole motors. Consequent pole motors intended to operate with 4-speed use 2 reconnectable windings. Like 2-speed or 3-speed motors, 4-speed motors can be wound to operate constant horsepower, constant torque, or variable torque. Some examples of the winding connections are 4-speed 2-winding 3-phase consequent pole motors as shown in the following image. A circuit for controlling a 4-speed 3-phase consequent pole motor can be seen in the above image. The control allows the speed to be selected by pushing the button that initiates the particular speed. In this circuit, stacked push buttons are used to break the circuit to any other speed before the starter that controls the selected speed is energized. Electrical interlocks are also used to ensure that 2 speeds cannot be energized at the same time. The low contact connection is also shown in the figure above. This circuit assumes the connection diagram for the motor is the same as the last image. The circuit also illustrates that the starter and contactors each contain 3 low contacts. Notice that third speed or high speed require the use of 2 contactors to supply the necessary number of load. context. As always, thank you guys for watching, and please like, share, and subscribe. And feel free to comment. Thank you so much for watching. See you in the next one.